This is assignment 7-7. Let's do the work together here. So this is the most important assignment you've done so far, because assignment 7-7 is a review assignment for unit 7 and all the prior units all together. So this is a great one to try to do. And remember to do this. Do your best first and then press play. So just don't always do the work with me. Try the work first, and then when you're stuck, keep trying, then press play to get support that you need. That way you will actually try to learn the material and not just copy it. All right, without using a calculator, list the domain, 2 points, graph, and the asymptote, then sketch on the same one, each graph in the same one. Okay, so A is, can you graph y equals e to the x? So 1 point on that is 0 and 1, and the other is 1 and e, which is about 2.7. And the asymptote is at y equals 0. On the same graph, we're going to graph y equals ln x. So these are inverses of each other. So if 0, 1 is on e to the x, then 1, 0 is on ln x, e1 is on ln x, and instead of y equals 0, it would be x equals 0. So I want to graph these together on the same graph. So for e to the x, we have 0, 1, and 1 and e, which is about 2.7. And we have an asymptote. I'm not going to draw the asymptote because it'll get a little confusing. So I'm just going to draw the curve without drawing the specific asymptote, but there is an asymptote at 0. That's e to the x. Ln x, we have one at, maybe I'll do this in a different color. I don't know if I have a different color. Whatever. So this is y equals e to the x. Ln x is 1, 0. And then you'd have 2, 1, 0, and 2.7, and 1. And then the asymptote would be over 0, but this would be the curve of ln x. So can you understand e to the x ln x? If you drew the line y equals x, they would reflect over that line. The domain for e to the x is all real numbers. The domain for ln x goes from 0 to infinity. So they do have a different domain. So ln x has a restriction where the numbers must be positive. Well, e to the x has no restriction. It goes forever left to right. Number 2, use adjustments, transformations, to sketch y equals e to the negative x subtract 3. So could you graph that? So what we just drew, the parent, y equals e to the x, we said the point 0, 1, 1e, and x equals 0 is on there. I'm going to transform them. What's in the exponent changes the x, and I do the inverse of what I see. So I'm going to divide by negative 1. So that only changes this value here. So 0 stays the same if you divide by negative 1. Oh, what did I do wrong here? This should say y equals 0. Thank you. And to this one's going to change. So we're going to subtract 3 to the y values. So this becomes, when you subtract 3, that would be negative 2. I got to get on my A game here. When you subtract 3, think of it as 2.7. Subtract 3. So kind of like negative 0.3 about. If you think of this as 2.7, and then we're going to graph that. So 0, negative 2, negative 1, and negative 0.3. And then there's an asymptote here. I didn't say the k value, negative 3, is the asymptote. So this is what the graph would look like. Four, write an equation for the line tangent at x equals 0. So do you see x equals 0 here? So if I drew the tangent line here, that's what the tangent line would look like. So for number 3, it says, what's the equation of that tangent line? So at that tangent line, x equals 0, y at that point is negative 2, And then I need the derivative of this. So the derivative of e to the negative x and negative 3. So e to the negative x, and the derivative of negative x is negative 1. So the slope, I would just plug in the x value, which is 0. Now 0 does not give you the answer 0, so don't go into that mode. So 0 gives you e to the 0, which is 1 times negative 1. So the slope there is negative 1, which makes sense. That looks like the slope of negative 1. And then put this all together, and you get y equals negative 1. X, I don't need x subtract 0. X is fine, and then subtract 2. You could also write it as negative x subtract 2, and that would be the correct answer. That's the equation of the tangent line that you just drew right there. Number 4. Number 4 is, I just did number 4. Oh, I skipped number 3. Ha! Sorry. So what I just did here was number 4. Sorry. Number 3 was to find the inverse. So let's just work backwards. And so if y equals e to the negative x subtract 3, what's the inverse? So that's x equals e to the negative y subtract 3. Add 3. Write this as a logarithm. So as a logarithm, it would be negative y equals ln x plus 3. And then to get y by itself, divide by negative 1. So you get y equals negative ln x plus 3. And then it says, for number 5, without differentiating, just double checking, it's fine. Oh, and number 3, it also says, what's the asymptote? So for here, the asymptote would be negative 3. Because that's right there. Negative 3 plus 3 makes it 0. It's the h value, right? Is what makes it, gives it the asymptote. So in number 5, it says, without differentiating, find the equation of the lines tangent to and normal to the graph that. When x equals negative 2 for the inverse. So if we're doing the inverse, x is negative 2 and y is 0 if we're doing the inverse. So we're taking what we did here and we're inversing it. So it's not 0, negative 2, but it's now negative 2, 0. And then the relationship is the reciprocal of what we just did. So we just found the slope to be negative 1 here. So the reciprocal of that is actually still negative 1. So the tangent line, then would be y equals negative 1, x subtract plus 2, sorry. And I don't need the 0 at the end. The normal line would be the opposite reciprocal. So you don't make that mistake. So perpendicular means it becomes positive 1. And everything else would be the same. So I know it's easy to get that mixed up. Reciprocal, opposite reciprocal, know when to apply what. So perpendicular means opposite reciprocal. And there's the equation of that line. Number 6. In number 6 it says, use a first derivative number line to show that f at x equals x subtract ln x is not 1-to-1. All right, so how can I show it's not monotonic? So the derivative of this is 1 over x. The derivative of x is 1, and the derivative of ln x is 1 over x. Make it equal to 0. So the first thing I know is that we have a critical number. Actually, we have a domain restriction here. So x must be greater than 0. So the domain restriction here already tells me that x can't be 0. So it's not a critical number because 0 is not in the domain. if I solve this, so if I add 1 over x and solve it, the only critical number to look at is positive 1. So positive 1 makes the first derivative 0. Then we're going to draw a number line for the first derivative for 1. And then into the derivative, we're going to plug in. So if I plug in a number, and make sure to know that this is right here, there's no negative numbers and not 0. So don't plug in 0. So you got to plug in a fraction between 0 and 1. So if I plug in 1/2 and do the reciprocal, you're going to get a negative answer. If I plug in a number bigger than 1, I get a positive answer. And you can see that f at x is not 1-to-1. Right? Because it decreases and then increases. It fails the horizontal line test. Because there's a turning point at x equals 1. All right, number 7. There it is. Number 7, without using a calculator, solve for x. So here's a review of logarithms. So without using a calculator, solve for x. So to solve for x here, write it as an exponential. So it's inside the logarithm, the base, and the exponent, and you have the answer. Number 8, if you know what you're doing, these are very quick questions. Oops, that says negative 2x plus 3. So again, e and ln undo each other. So you're just left with negative 2x plus 3 equals 5. And it's important to know that if you plug negative 1 in for x, a negative times a negative gives you a positive answer inside the logarithm. Otherwise, it might be extraneous, and you might have to cross it out. But negative 1 is a good answer. It gives a positive answer inside the logarithm. Number 9. All right. So for this one, what will make this, again, we're going to write this exponentially. So inside the logarithm is 2x subtract 1. The base is e to the exponent 0. So we have 2x subtract 1 is equal to 1. And keep those absolute value bars. Now to remove the absolute value bars, this answer could be positive or negative, and then solve it. So I would add 1 and then divide by 2. So you're just going to have to figure this out as we add 1 and divide by 2. So start with positive 1. 1 plus 1 is 2 divided by 2. So one answer is 1. Or negative 1 plus 1 is 0 divided by 2 is 0. So the answer positive 1 or the answer 0, both would work. Number 10. We have log base 3x, log base 3, 2x plus 1, minus log, and the base is 3, x plus 4, and then plus 1 outside the parentheses. All right, so this is a property of logarithms 1 before we write it exponentially. So on the right side, if I want to write this as one logarithm, subtracting means I'm going to divide. So I'm going to divide these to write it as one logarithm. Now, because they both have the same base, there's different ways you can approach this. So I'm going to approach it this way. I'm going to write 1 with the same base. So if it has the base 3 and 3 inside, log 3 base 3 is 1, and now all the bases are the same. So I'm going to write the right side as one logarithm now. So if you're adding, it means you multiply. So I'm going to multiply by 3. There it is. Now that the bases are the same and log, I can just let what's on the inside equal each other. So x equals 6x plus 3 over x plus 4. I'm going to multiply both sides by x plus 4. I'm going to combine like terms. So it's a quadratic equation, so I'm going to subtract 6x and subtract 3. It factors out pretty easily. So the two numbers are negative 3 and positive 1. So each factor has a solution. I just got to be careful of extraneous solutions. So positive 3 and negative 1. So if I go back to the question, a logarithm cannot have a negative number inside. So positive 3 is okay, but negative 1 is bad. It's extraneous. So the only correct answer is positive 3 for this equation. Number 11. We have 4 to the exponent 3, 8 to the exponent 2x subtract 1, just pre-calculus. Make the bases the same, and then solve the exponents. So pretty simple. Make both bases into 2, and then I got 2 to the exponent 6, 2 to the exponent 6x subtract 3. Make the exponents equal to each other, and then solve it. Add 3 and then divide by 6. All right, number 12. We're going to get into calculus now. Those are pre-calculus, good review questions. G at t is equal to t cubed, e to the negative t. And it says take the derivative of that. So if I want to take the derivative of this is the product rule. The first times the derivative of the second plus the second times the derivative of the first. You don't have to simplify it. Number 13. Y equals e to the x squared subtract 1. Take the derivative of this. That's e to the x squared subtract 1 times 2x. That's it. Oh, it asks you for 13 to do the second derivative. So the second derivative is going to be the product rule. That's the first times the derivative of the second plus the second times the derivative of the first. You don't have to simplify it. In number 14, take the derivative. Let me do 14 over here. Take the derivative of ln x squared subtract 1 for x. So this derivative is going to be the quotient rule. So the quotient rule is the bottom times the derivative of the top. So what you see is the denominator, and then the numerator is the derivative of that. Subtract the top times the derivative of the bottom, which is just 1, and then the bottom squared. Be a good rule follower. Number 15. Y cubed subtract x, y ln x. So this is going to be implicit differentiation. So again, always pause and try it first. It's a video, so you don't have to go up my pace. That's 3y squared times the hook, y prime, minus 1. And then this is the product rule. So the first times the derivative of the second plus the second times the derivative of the first. So the derivative of y is 1, but it needs the hook on y prime. So recognize what has a y prime. So 3y squared. And this on the right, so we're going to subtract ln x, y prime. And then if it doesn't have a y prime, we're going to add it to the other side. So that's y over x plus 1. Now factor out a y prime. And then divide. Again, it's okay if it looks ugly a little. Fractions within fractions are pretty to me. So then you have y over x plus 1 over 3y squared minus ln x. Number 16. Think of all the paper I use so that you guys can learn. It's okay. 16. Y equals ln x squared. Now I'm going to write the next one as exponent. So that's x plus 1 to the 1/3. And now I want to take the derivative of that. Right. All right. So the rule is what's inside you copy. That's the denominator. And then the numerator is the derivative of that. So that's the product rule. That's the first times the derivative of the second plus the second times the derivative of the first. Done. Always checking my answer key to make sure that we're matching. You could also have used properties of logarithms to simplify it. So if you wanted to use properties of logarithms, you could, or you could have done the product rule like I did. Both would be correct. 17. There's no property here because that 3 is on the outside of the logarithm, not inside the logarithm, that exponent. All right, so the power rule is 3 times 4 is 12. Subtract 1 to the exponent times the derivative of what's inside. That's a fraction. So what you see, x squared plus 1, that's in the denominator. The derivative is 2x, but then it needs the hook ln 3 as an extra hook at the end. Or ln, did I say 3? How did that base change to 3? That's a 6. Ln 6. Perfect. All right, number 18. So next page. In number 18, y equals c to the exponent c. It says, if possible, differentiate each function. Assume c and c are constants. And one example is not possible with techniques you have learned. So note the differences in each problem. So a constant to the exponent that's a constant would mean the derivative of this would be 0. Number 19, because the derivative of any constant is 0. Y equals x to the c. The derivative of that would be c times x, and then you'd subtract 1 to the exponent. Number 20, y equals c to the x. So that's a constant to the exponent x. So the derivative of that would be you copy it times the derivative of the exponent, which is 1, but then we need a ln c at the end. And if that was an e, ln e would be 1, so it would just be c to the x. But we need that hook on ln c. 21, this is the one that's not possible. So y equals x to the exponent x is not possible using current methods. You could use your calculator. So that's a very unique equation, isn't it? X to the exponent x. So that is not possible with the methods we have. 22. These are integration questions. So we're integrating from 0 to 1, and we're integrating x squared plus 1. That's the denominator. Now I'm already going to get into the first step. The derivative of x squared plus 1 is 2x. That's the correct hook that we need in the numerator. It's 3x. So I need a 2/3. What it was over what it became. So I need a 3 over 2. So that's 3 over 2. So if I multiply it, the 2's divide out and you get 3x, so it stays the same. So then I can unhook this. And I have 3 halves. That's ln, make sure you remember the bars, x squared plus 1 and it's an indefinite integral, so I'm going to do a substitution. There's no plus c at the end. And then you plug in the upper limit. So plug in 1 and you get ln 2. Subtract, plug in 0 and you get ln 1, which is 0. So really this is just the answer here. 23. We're integrating from -1 to 0. And what I notice is we have a monomial in the denominator. So that's the indicator to know we're going to write this as multiple fractions. E to the 2t over e to the t plus e to the t over e to the t, subtract 2 over e to the t, and there we go. So there's the first step. And then we're going to simplify each one. So e to the 2t over e to the t, the bases are the same. You're dividing, subtract the exponents, and you get e to the 1t. E to the t divided by e to the t is 1. And then we're going to rewrite this as -2 e to the negative t. Now we have the ability to integrate this. So the integration of e to the t is e to the t. The integration of 1 is just 1t. And then the integration of -2 to the e to the negative t would be -2 to the negative e there. So we just copy it, except the hook on was negative, so this has to become positive for it to work. And we're got a substitution. So we're integrating from -1 to 0. So now plug in a 0 first. Feel free to simplify if you want or not. So e to the 0 is 1, plus 0 is still 1, and then e to the 0 is 1. So that's just 1 plus 2, which is 3. And then the second one, plug in -1. And you don't have to simplify it. You could simplify it if it asked you to. All right, number 24. So those were definite integrals, fundamental theorem of calculus, where we do a substitution at the end and subtract. These are now going to be indefinite integrals, where we just need to remember the constant at the end when we integrate. So again, the first thing I notice is a monomial 3t. So I'm going to write it as t squared over 3t plus 1 over 3t. And then I'm going to simplify it. Oh, you know what also I notice? That's fine. No, that works. So t squared over 3t simplifies to t goes into just t over 3. And this is 1 over 3t. So t over 3 is just t squared. So add 1 to the exponent. And then divide, which makes it t squared over 6. Because that 2 times 3 in the bottom. 1 over 3t is a logarithm. And we need that 1 over t is ln t. So it's 1/3 ln t. And you have to remember the bars. And then plus c. Number 25. It's always more challenging to integrate. Thinking it through, what your strategy is. A derivative rule is just, here's the rule, follow it. Integration is more fun. So x cubed over x squared plus 1. We don't have a monomial in the denominator. The numerator is more powerful. So because the degree is greater on top, I have to do long division to simplify this first. So long division would be x squared plus 1 into x cubed. So this would be x. So divide, x cubed divided by x squared is x, and then multiply. Subtract. What's left over is negative x. So what's left over, the degree is smaller than what I'm dividing by. So I can come back here again and realize the answer is x. And then the remainder is minus x over x squared plus 1. Now I can integrate this. So x, the integration is add 1 to the exponent and divide. This is going to be a logarithm. So if I handle it separately, let me just do it in 2 steps here. So the derivative of x squared plus 1 is 2x, what it was and what it became. So I need a 1/2 in front here. So I have x squared over 2. And now I can unhook this, and I have 1/2 ln x squared plus 1. Again, don't forget the bars or the candy bars for number 25. Number 26. In number 26, you're integrating dy, y, ln y, 3. This looks complicated, but if you can see what I see, it's not too bad. So if you integrate, this is really 1 over y. And ln y to the 3 can be written as ln y to the negative 3. So if you can see that, then you could see the derivative of ln y is 1 over y, which is correct. So I just unhook it and add 1 to the exponent and divide by it. And then don't forget the constant. Done. Again, that's what makes integrating more fun, to try to see the different ways it could be and to be able to solve it that way. Derivatives are a lot simple, sometimes too simple. 27. Again, I have e to the exponent root x subtract 2 over root x dx. So for 27, let's see what we can do. So this is really x to the negative 1/2 without a fraction. And then we have e to x to the positive 1/2 subtract 2, all in the exponent. So that's what it looks like if you make it calculus friendly. Now, the derivative of the exponent there, x to the 1/2, is 1/2 x to the negative 1/2. So that's the hook on that it needs. So if I look, the only difference is the 1/2. So what it was or became, so I need a 2 in front. So when I multiply it, it stays the same. Then I can circle the entire hook and unhook it. And then you have 2, and the rule for this is just copy it. And don't forget the constant. 28. So the antiderivative of 3 over x is 3 ln x. And then I plug in negative e to negative 1. So first I plug in negative 1. And then I plug in e. So if I simplify this, or negative e, right? Negative e. So if I wanted or had to simplify it, the absolute value of negative 1 is 1. So ln 1 is 0. So this is just 0. Ln, and the absolute value of negative e is e. So ln e is 1. So this is just 3 times 1. So if you simplify it, the answer would just be negative 3. All right, 29. We're getting there. Do you see the sun on me? I got a little bit more time before it goes right through my head. So I can do this. Find the average value of this on the interval e to e squared. Looks worse than it is. So average value is this. You integrate the function and divide by the difference in the bounds. So the lower bound is e, the upper bound is e squared. So you subtract the bounds in front. That'd be e squared subtract e. So I'm going to write that as a fraction, e squared subtract e in front, and then not be bothered by it for the rest of the question. Then I'm going to integrate this up here. So I'm going to write this as 1 over t ln t squared. And again, I'm integrating from e to e squared right here. So I write it as 1 over t and then ln t squared. So the derivative of ln t is 1 over t. So that's the correct hook. So I can unhook it. So I still have this in front. And then the rule is add 1 to the exponent and divide. And I'm integrating from e to e squared. So this 3 in the denominator, it can join e squared minus e if you like. And then we're going to plug in. So start with the upper limit. So that's ln e squared cubed minus ln e cubed. So if I had to simplify this, I could. So this is ln e to the 6th minus ln e cubed. No. Ignore that. So ln e squared is just 2. Ln e cubed, ln e, they simplify out, leave me with 3. So it's just 2 take away 3. So ln e, you get 2. Oh, and you're cubing it. And then ln e leaves you with 3. So that's 8 take away 3. So it's going to be 5 over this. Pretty challenging, right? All right. Making sure I did it right. The answer key is just a little bit different. It has 8 take away 1. Everything else is the same. So let me just double check to make sure. If I plug in e in here, I got ln e cubed. All right. So ln e is 1 and 1 cubed is 1. That's why it was wrong. So this should be 1. So 2 cubed subtract 1. That's 7. Now we're right. See? Easy peasy. This was a challenging question. I get it. All right, number 30. We're almost there. So in number 30, the limit as x approaches infinity of x times 2x subtract 3 squared all over x cubed plus 10. Now, what this is asking for is the right end behavior, which is another way of saying what's the power term and the right end behavior of the power term. So, in the numerator, 2x squared is 4x squared. So that's why it's 4x cubed when you multiply it out. So this is 4x squared times x, and then x cubed. So if I divide out the x cubes, the right behavior, and the answer is 4. Number 30, 31. Is the same? Nope, not the same question. So limit as x approaches infinity. This time it's x times 2x subtract 3 over x cubed plus 10. So I want you to notice that when you multiply the numerator out, the denominator is more powerful than the numerator, which means the end behavior is always 0 when the top is less powerful. So 2x squared over x cubed. If the bottom is more powerful, the end behavior is 0. 32. In 32, you're given the point 2, negative 1, and we have a function f at x equals x cubed plus x subtract 11. And it says, find the derivative of the inverse. So our goal is to find this, right? So step one here is we're going to take the derivative of f of x. That's 3x squared plus 1. We're going to plug 2. We're going to plug 2 into here. That gives me 13. Then I'm going to understand this, that the derivative at 2 and what I'm looking for are reciprocals. So these are reciprocals. So what I'm looking for, the reciprocal of that, and you have your answer. It's 1 over 13. Number 33. So number 33, g at x equals e to the x plus 3x. And it says find the derivative of the inverse at 1. So this is my goal. Given that. So for the inverse, the x value is 1. For g at x, that would be the y value. So I'm going to make it equal to 1. And then I'm going to solve it. So there's no quick way to do it. You could do it with the calculator. If you plug in 0 for x, e to the 0 is 1, and 3 times 0 is 0. It works. So you can guess and check or use your calculator. But the answer to that is 0. So when I take the derivative of g at x, which is e to the x plus 3, then I plug in what I just found, which is 0. So e to the 0 is 1 plus 3 is 4. Then when I do the inverse, it's the reciprocal, and you get the answer a quarter. All right, number 34. If you need a break, you press pause. If you're willing to fight your way through this, let's do it. Almost. Again, this thing's getting closer and closer to my head. So when that's done, I'm done. So the region R is bounded by y equals e to the x equals 0, x equals 2, and y equals 0. So I'm going to graph that. So there's y equals e to the x equals 0, x equals 2, and y equals 0. So it's this region right here. And the question number 1 is, A, sketch a graph and shade it. There it is. That's A. B, find the area of that region. So to find the area of that region, I'm going to integrate from 0 to 2. I'm going to integrate top, subtract bottom. So it's just e to the x, subtract 0, or e to the x. The integration of e to the x is e to the x. And then plug in the upper bound, subtract the lower bound. So it's really e to the 2, subtract 1, or just e to the 2, subtract e to the 0. Part C says find the volume if you revolve it around the x-axis. So if I revolve around the x, this area is touching the axes all the way through. So it's a disk. So it's a pi r squared, again from 0 to 2. And the radius, again, is top subtract bottom. So that's e to the x subtract 0, or just e to the x. To find the volume, we're going to simplify it first. So e to the x to the exponent 2 is e to the 2x when you multiply the exponents together. The derivative of e to the 2x is 2, the exponent, so I need over a 1/2 or over 2 in front, so they stay the same, so we have the right hook. So unhook 2, So I have pi over 2. The rule for e to the 2x is you copy it, and then I'm integrating from 0 to 2. And then I plug in the upper bound. You can leave pi over 2 in front. So that's e to the 4 subtract e to the 0. Done. D. In part D, it says set up an integral, but don't do it. And you're going to revolve about the line y equals 9. So if I go around y equals 9, let's say it's way up here, y equals 9, I realize it's a washer, right, when I revolve around it. So we have a big radius that goes all the way through, and then a small radius. So the big radius that goes all the way through would be 9 take away 0, or just 9. So in part D, to set this up, it's a circle. Again here, right? We have a big radius minus a small radius. So there's what it looks like. A big radius take away. So we just found the big radius is 9. And then the small radius, again, is the top subtract the bottom, which is the curve. So it's 9 subtract e to the x. That's the little radius and the big radius. E. So there it is right there. E. Set up a volume with semicircles. Diameters lie perpendicular to the x. So for a semicircle, it's half a circle with that radius. So it's half a circle, so it's 1/2 pi r squared. And then what I see here, top subtract bottom, is actually the diameter. So the diameter is e to the x. So the radius is half of that. So it's half the circle and half the diameter, and then the setup. $35. It's getting closer, right? Do you see it? 35. So the derivative is 1/2 e to the negative x. F at 2 equals 1 over 2 e squared. And then it says find f at x. So I'm first going to do the antiderivative. So to do that, the derivative of negative x, I need negative. So it's going to be negative 1/2 e to the negative x plus c. And then I need to plug in. So plug in 1 over 2e squared into this. Now recognize, oops, let's pause it, that we have negative 1 over 2e squared. So if I rewrite it, maybe you could see it. So if I add 1 to the other side, it would actually be 2 over 2e squared. The 2's simplify out. So that, and you could also write that as e to the negative 2. But that's fine, just the way it looks. So then f at x would be, if you put it all together, would be negative 1/2 e to the negative 2, and then c is 1 over e squared. Remember from the here, negative 1/2 e to the negative x. All the other work was to find c. Oops, this should be x then, shouldn't it? So negative 1/2 e to the negative x, and then our c was 1 over e squared. All right, 36, 2 left. So in 36, the derivative is ln x subtract e to the x. And you're given f at 2 equals 3, and then use a calculator to find, oh, I like that, what f at 4 equals. Okay, so that's my goal. So f at 4 is equal to, so if I'm given the derivative, I'm going to integrate from where I started. So I know 2. So I'm integrating from 2 to 4, the derivative. So I'm going to integrate and add that to the starting value, which is 3. So again, I'm going to integrate from 2 to 4, the derivative. That will tell me the increase or decrease. And then you add the starting value of 3, and that's what you put in your calculator. Now, I've charged my calculator, so this should work now. So we're almost there before that sun gets me. So here, this is what it would look like in your calculator. All right. So I'm going to do integration. So menu, calculus, integrate. And I'm integrating from 2 to 4. And then inside the integration is ln x subtract e to the x. So there's the integration part. And then add 3 to it. Control enter. So I get negative 42.050. So negative 42.050. All right, last question. 37. If the area of a rectangle shown is increasing at that rate, find dx by dt. So let's start with this. Area is length times width. If I look and write this as an equation, the length and width would be x times ln x. If I take the derivative with respect to time, it'd be the derivative of the area with respect to time, and then the product rule. The first times the derivative of the second, and it needs a dx by dt, plus the second times the derivative of the first, but again, whenever x is involved with respect to time, we need a dx by dt. In the question, it says the area is increasing at a rate of 4 centimeters squared. So dA by dt is 4. X times 1 over x is just 1. So that's just dx by dt. And then I have ln x dx by dt. Does it tell you what x equals? X equals e. So let's plug that in. So x is equal to e centimeters. Ln e is just 1. So if this is 1 and I add them together, I have 2 dx by dt's. Because ln e is equal to 1, it's 1 times dx by dt. So if I add them together, I have 2 dx by dt's. Divide by 2, and then make sure you have the correct units involved. So 2 is the answer, and the correct unit would be centimeters per second, right? Yeah. That's the rate x is increasing by. And you have your answer. Hey! And the sun is so close, but you know what? I did it. Mr. G Math over and out. I'm proud of you for doing your work. Until next time.